Hello everybody. Let's quickly solve a geometry question today. Alright, what we're going to take is a positive integer n, okay, a positive integer n whose value is at least 2, whose value is at least 2. And we're given a square O, A1, A2, A3 whose side is A. Alright, and we put identical squares on top of the given square O, A1, A2, A3. Let's call it the base square, okay? Let's call this square a base square. And on top of the base square, we have a square A2, A3, let's say A4, A5, which is identical to the base square. And on top of this square, we have another identical square, and so on and so forth. So that we have n different squares. This is the first square. This is the second square. We have the third square somewhere over here, fourth, all the way up to n squares. Similarly, all the way up to n squares, n identical squares. Okay, so this is also a, 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 and these are also a. All right, and under these conditions, what we need to do is we need to find the area of triangle OBS. So OBS, this triangle. All right, this triangle. Now, to find the area of the triangle, we can use several different ways. We can use several different methods. All right. The one I'm going to do is I'm going to use the basic formula, the most simple formula, half times base times height. So I'm going to take OB as the height, OB as the base, and let's say this is SS dash as the height. So what we have, OBS. All right. So I'm going to take this as the base, this is the base, and this as the height, like this. All right. So first we need the length OB. So if there's only one square, this length is A. So if there are two squares, the length is 2A. So since we have n squares, this whole length is equal to n times A. Okay? N times A. N times A. So we have this length as n times A. So all we need to do is find SS dash in order to find the area of the triangle OBS. All right. So for this, you can use several methods, okay, to find the length SS dash. You can use many different methods. You can use similarity if you want, but I'm not going to do that. I'm going to introduce a coordinate system to obtain the coordinate of the point S and hence the length SS dash. All right. So I'm going to use a coordinate system because coordinate system especially it's really useful if we have polygons and circles, and really useful if the polygon is a rectangle or a square. All right. Okay. So you can take your origin wherever you want, positive x-axis wherever you want, positive y-axis wherever you want, provided that you have mutually perpendicular lines. Or if you want to use oblique coordinates, you can do that too. So I'm going to take my origin at O, very convenient. I'm going to take my positive x-axis along OQ and my positive y-axis along OB, like this. Okay, so To find the coordinate of the point S, S is the intersection of the line BA1 and OP. Okay, OP. So we need to find the equation of these two lines, BA1 and OP, and solve them by taking them as a system. Okay, a system of equations representing BA1 and OP. All right, we're going to solve that system and find the coordinates of S. That's the main task. All right, so to find the equation of BA1, what we can do is we can use the double intercept form. So this is the x-intercept, this is the y-intercept. X-intercept is of length A, so the coordinates of the code, okay, I'm not going to use these anymore. So the coordinates of A1 is A, 0. Similarly, the coordinates of B are 0, the length is NA, so NA. So A is the x-intercept, NA is the y-intercept, so that the equation of BA1, okay, equation of BA1 is, oh god, equation of BA1 is x over the x-intercept, which is A, plus y over the y-intercept, which is NA, equals to 1. Now if we multiply both sides by NA, we're going to get NX plus y equals NA. Alright, let's call it equation 1. Now to find the equation of this line OP, what we can do is that we already have a coordinate of one of the points on the line O, which is the origin, so its coordinates are 0, 0. And let's see, OQ, just like we have obtained this length to be NA, we can obtain this length to be NA as well, OQ to be NA as well, because there's one square, the length is A. We have two squares, A plus A, which is 2A. So similarly, if we have n different squares, this length will be n times A. All right, this length will be n times A, and since this side is A, we're going to have PQ is equal to A. Okay, so we're going to obtain the coordinates of we're going to obtain the coordinates of P by looking at these lengths, which is NA and A. So the x coordinate is NA, all right, and the y coordinate is A. So now we can find the equation of OP. We can find equation of OP. All right, the equation of OP. The equation of OP is, since the line passes through origin, takes the form, and it is not parallel to y-axis. It takes the form y equals mx, and where m is given by A over NA, which is 1 over n. All right. Now, to find the coordinates of S, we're going to solve 1 and 2, the system of equations which we obtained by taking the equations 1 and 2. Okay, because it is the point of intersection, S is the point of intersection of the line BA1 and OP. So we're going to solve these two as a system, which gives, if we take y equals 1 over n times x to this equation, we're going to get nx as it is. Y is 1 over n times x over n, okay, equals n times a. So this is going to give n square plus 1 times x equals n square a. All right, n square a, which means x is equal to n square by n square plus 1 times a. Okay, so we've obtained the value of a. Now let's look at this. We can solve for y, we can find the value of y, corresponding value of y, but we're not going to do that because what do we have? This is some b is somewhere over here. This is positive y-axis, right? Here's the origin, and here's the point S. Here's the point S, and we're required to find this length, S dash, isn't it? Positive x-axis is somewhere over here. So if we look at this part, only this part, we need S dash, right? So this length will be the x coordinate, and this length will be the y coordinate. Y coordinate, isn't it? Right? This length will be y coordinate. So since this is a rectangle, we're going to have this length to be given by the x coordinate of the point S. So this length S dash is actually the x coordinate of, in fact it's the absolute value of the x coordinate, but we are only dealing with the positive quadrant. Okay, the first quadrant, we can take the length and what do you call the coordinates to be identical. All right, so S dash is the x coordinate of S. The x coordinate of S is this. So what do we have? So what we have is this to be x coordinate of S is n squared by n squared plus 1 times a. This was n times a. So we're basically done. Okay, we're basically done. So triangle OBS is equal to half times OB times SS dash, which is equal to half times OB is equal to n times a times SS dash is n squared by n squared plus 1 times a. So if we simplify this, this reduces to n cubed a twice n cubed a squared twice n squared plus 1, which is the required area of triangle OBS. And as a simple example, let's see, if n is equal to 2, we're going to have 8 times a cube all over 2 times 2 squared plus 1. Okay? Sorry, a squared, which is equal to 4 by 5 a squared. Alright, similarly, if we put n equal to 3, we're going to get a similar result. Alright, so this is the general formula for such arrangements of squares. Okay? Alright, thank you very much.